Again, for here, talking about key characteristics, I can identify characteristics of linear functions from graphs and from context. There is some problems, or there are some problems in which you are not able to describe what a domain or what a range represents if you don't have context. Context means that there is a real world connection to the graph. If they just give you a graph like these, there's no context to what your domain represents or what your range represents. But we can describe interval values or types of values that are related to our domain and range. With context, a word problem or a real world format, then we can start describing what they are going to represent. So this is just a quick reminder of how to write our interval representation for our domains and our range. Here, Mallory owns a lawn mowing service. She borrows $400 from her aunt. So since she borrowed money, that's why they are starting her off at negative $400. She is now in debt at $400 before she starts mowing, which is what that value 0, negative 400 represents. That before she starts mowing any lawns, she is in debt of $400 because she wants to pay her aunt back. So the graph compares the number of weeks, meaning as she is mowing lawns and she's earning money, compared to the profit. So she doesn't make a profit. She doesn't make an actual profit until she finishes paying her aunt back. So over the first few weeks, she's going to be working on taking all the money she earns and giving it back to her aunt until she gets to what point? At what week has she broke even? Richard? At 4. At 4 weeks, she broke even. We know this is because now she's at $0 for how much money she's profited. Okay, she doesn't owe anything, but she hasn't earned any money for herself yet either. So she's at the break-even point at 4 weeks. Once she moves past that 4 weeks, then we can start stating that she's earning profit for keeps, not for paying back debt. Okay? So looking at what this represents versus the graph, we can connect those real-world situations to a domain value, which is our x, and to a y value, our range value, which is our y. Okay? So for algebraic notation, our domain, our minimum point that the domain can be is what value? What's the smallest point our domain, our x value, can be? Andreas? 0. The minimum value that our domain can be, which is located right here, that's as far to the left as our graph is going to be able to go, is 0. Because you can't have negative weeks, can you? So 0 is the minimum value that it's potentially able to be. So when we're looking at this, I know that it has to be greater than 0. I know that my x is going to be greater than 0. Now notice that as my line goes on, I have an arrow at the end of my graph. What does that arrow mean? What does that arrow mean is going to happen, Zach?
It's going to keep going. Her profit's going to keep going up, and so is the number of weeks.
So her profit's going to keep going up, and so are the number of weeks. So do we have any end value in mind? No. So all I can do is write down that x is always going to have to be greater than, or sorry, equal to, because we are starting there, greater than or equal to 0. It's going to be greater than or equal to 0. The fact that we are going to continue going on forever in that direction means that it's going to be greater than or equal to 0. Our range, the lowest point that our range is going to start on, which is our y, the lowest point that our y is going to start at is what value? Looking at our graph, what's the lowest point that our y is going to start at? Jeffrey?
Negative 4.
negative 400, okay? So I know that it has to be greater than or equal to negative 400. And again, just like Zachary said, it's going to continue going. Her profit is never going to stop as long as her weeks don't stop. So as her weeks are always going to be getting larger, so is her profit. So now we're just relating it to our words. Okay, so for our meaning, the meaning in words is that you are going to continue working on forever for an unknown amount of weeks. Okay, so domain represents the weeks of mowing. Domain is going to represent the number of weeks that she spends mowing. The range is going to represent the profit, money profit. From mowing. So a characteristic that we can see here is that as she progresses throughout the weeks, her profit starts to improve. Her profit is going to continuously increase. Okay? So that's what we're trying to get into for here, is characteristics. What does that line represent? What do those points represent? So taking a look here, characteristics of functions. Again, we're going back with this Mallory's lawn service. Okay, she borrows money from her aunt. This is the graph that we've got here at negative 400. It's the same exact graph. We're going to talk about the interval of positive values. At what point do we only focus on positive values? At what point is our interval focusing on negative values? And what is our end behavior? These are all things that describe the characteristics of our graph or of our context. So the first thing that I want to talk about is, what does it mean by our interval values for positive and negative? So one of the things that you want to make sure that you're focusing on, go ahead and write a star note here. The interval, when we discuss the interval in these situations always pertains to the X location. Or our X values. When we're talking about our interval of positives and interval of negatives, we're focusing on basically reading the graph from left to right. In fact, I want to put that down. You're going to think about reading the graph. Think of reading the graph from left to right. Always along your x-axis. Okay, it's always going to be based off of the x-axis. So if we're starting on our x-axis and we're reading it from left to right, we want to identify at what point are our values going to be positive and at what point are our values going to be negative. So let's start off first with our positive. At what value of x are our points going to be positive? What value of x up here? So remember, this is your x-axis. At what point are we going to start moving into positive values? Start thinking. Talk with your table. Discuss it with your table. Looking at your graph, here's our x values. We've got 0, we've got 1, we've got 2, we've got 3, we've got 4, we've got 5, and it continues on. At what point does our line progress into a positive zone? Talk with your table. Huh?
But think of reading the graph from left to right.
Oh, oops. Thank you. All right, come back in 3, 2, 1. At what point does our line progress into a positive nature? David? So at 0, at 4. All right, at 4, so not at 4, but greater than 4. Because if it's at 4, if we're just focusing on the value 4, is our money positive? Is our money negative? No, our money is 0. 0 is neither a positive number or a negative number. It is a whole number, but it's not considered positive. It's not considered negative. So we are looking at everything greater than x being 4. So the interval of positive, that's going to be located right here. This is our location of where things start to progress into the positive zone, where x is greater than 4. Okay, so let's write that information down as well, that the positive regions of the function are those intervals where the function is above the x-axis. Okay, so you're looking at what point are we above the x-axis, where y starts to become positive. So your y values are positive. Okay, the positive regions of the function are those intervals where the function is above the x-axis and your y values are positive. So that's what I'm highlighting here in that green zone. Now when we're focusing on intervals of negative values, that's when we're going to start falling below the x-axis, where our y values are considered to be negative. So it's basically the opposite of what we wrote here. That's going to be this entire zone. But only to an extent. The reason I say it's only to an extent is because we know that we can't go less than 0 weeks, can we? So it has to be the values that are between 0 weeks and 4 weeks. So if I were to write this, remember, if I write x has to be greater than 0, but x also has to be less than 4, x has to be greater than 0, but x has to be less than 4, then when we write that as an entire statement, I would just flip this first inequality. I would say that 0 is less than x, which is less than 4. That's what we're trying to indicate. We like to write them as a single inequality. And the negative regions are those intervals where the function is below x-axis. And that means that we're talking about y values are negative. Okay, so that's really important to make sure you understand. You are focusing on y values that have now become negative. It's when you are falling below. Your line or your function values or your function graph is below your x-axis. So now here's what they mean when they're talking about the end behaviors. You're basically just talking about the relationship, the pattern that you're seeing here. So in this situation, our end behavior of the function, it's going to indicate that the number of days, as your number of weeks increase, then so does your profit. Your profit is going to also increase. So as the weeks increase, so does the profit. As the weeks are increasing, so is the profit. All right, go ahead and flip that on over to the back once you've gotten that written down. I'll pause. So what we're going to do is we're going to work on this problem together. Now notice that when we're discussing what domain and range are, it's not asking me what it represents. This is because there's no context here. This is just a situation in which they are giving me a function without a context. So I can't potentially describe what does the domain represent, what does the range represent. If they give you context, you should always indicate, when they're asking for domain and range, you should always indicate what it represents as well. So there are very specific characteristics that you can describe when you're given context versus when you're not. So let's take a look first. This line has already been graphed, showcasing the equation y is equal to negative half x minus 3. We want to indicate what the domain values are going to be and what the range values are going to be. This is a continual graph. Remember, we talked yesterday about what it meant to be continual. Continual is another way of saying it's connected. You are able to create a line. Does anybody remember what I said when they were dotted? Anybody remember what it was called? Discrete. Think discrete, dotted. When it's continual, it's connected. So when it's very specific points, that's represented by those dots instead of lines. The dots are considered discrete information, very, defined information. Okay, so for our domain, in this situation, our domain, which is our x values, we have arrows on both ends. So in a situation like that where you've got arrows on both ends, it means it's continual in both directions. So that means that x is going to be greater than or equal to a positive infinity, and x is also going to be less than or equal to a negative infinity. I just need to rewrite one of those. I'm going to go ahead and rewrite my negative, or sorry, no, I miswrote that. Less than or equal to and greater than or equal to. I apologize. X is less than or equal to positive infinity and greater than or equal to negative infinity. If I were to go ahead and write that as one whole statement, it would be negative infinity is less than or equal to x, which is less than or equal to positive infinity. This showcases that the value is going to go on in all directions. You could also state that it is all real values. Same thing for the range, except instead of x, we're just going to put a y. So it's following the same pattern, that negative infinity is less than or equal to our y values, which is less than or equal to positive infinity, or the set of all real values. So now what we're going to do is we're going to identify at what point is the interval going to be representing positive values. So remember, we only focus at x-axis. So at what point do we now have our function extending above the x-axis? Take a look at your graph, look at your paper. At what point does our line, our function, extend above the x-axis? Montserrat? Not quite at 8. 8, it's already well above. It's 6. Starting at the value of 6, we're going to go ahead and be able to extend above the x-axis. So that means that x is going to be greater than 6. When x is greater than 6, that's when we start extending above the x-axis. So that means the opposite of it, when x is less than 6, that's where we're going to fall below the x-axis. So when x is less than 6, When x is less than 6 is when we start falling below. So then our end behavior here, as our x increases, so does our y. As the x increases, so does the y. All right, what I want you guys to do is you are going to answer the characteristics. You're going to fill in the characteristic table for the contextual problem. I also want you to indicate what the domain and range represent. Don't just give me your intervals, but give me the representation of it as well. And then I want you to go ahead and answer the agree or disagree scenario at the bottom. So you're going to do that together, and then we'll go over it tomorrow. So make sure you're focusing on that right now. This is like your homework. We're going to go over it tomorrow. It's not a graded homework, but you need to be prepared to discuss.